Hello guys, today we have another video review that has to do with a programmable controller by Flipsky company. This particular controller is a new model MiniV6.8 Plus. On this little thing we can do a ton of programming. It is based on VESC 6 and it is programmable via VESC tool. There we can program almost everything, such as adjusting flux weakening to increase maximum speeds. We can choose analog region brake, for example we can work our region brakes through a second throttle. We can make it work as BLDC controller or as FOC controller, and much more. At the bottom of the device there are the connectors for signal wiring, and the functions of each cable is indicated on the surface of the device, which is very convenient to find the function of each cable without having to search for manuals every time. It is very small and is ideal for micromobility, like electric scooters, hoverboards, monowheels, electric bicycles and motorbikes. At first glance, the device is quite solid, with an aluminum casing which works like a heatsink. In the box with the device also includes signal wires, USB Type-C for programming, power connectors, heat shrinks and the manual. Now let's say a few things about the specifications. Working voltage from 50 volts to 60 volts or 3 to 13 series, but for safety reasons the company recommends max at 12S, which is 50 volts with region spikes until 60 volts maximum. So here we have to double check our system voltage to avoid damage on electronics. Maximum operating current at 150 amps, and we can increase it up to 200 amps if we have a heatsink. Note that this current numbers is for motor phases, not for battery current. Look at these massive connectors. They are huge and they make very tight contact between them. A small minus from my point of view is that the connectors are facing upwards instead of coming out from the sides, which will be more convenient for the user. Now it is time to open the controller and take a look from inside. Here you can see that the temperature transmission from the MOSFET to the heatsink is through thermal paste. In this particular case, I would prefer a thermal patch. At the top of the board we see only capacitors and connectors. So let's clean the bottom from the thermal paste to see the model of the MOSFETs that this particular controller hides. Here we see the model of the MOSFET, which is 5C628L. With a quick search on the internet we find the PDF file with specs of this particular MOSFET, which is N-channel 60 volts 150 amps with a maximum drain source voltage at 60 volts. Here we understand why the company emphasizes the maximum voltage at 60 volts. As we can see in the circuit, for each phases there are 6 MOSFETs. 3 are for positive waveforms and 3 for the negative waveforms. The metal bars that we see are mainly for cooling the circuit board, like thermal capacitors, which in turn cools the MOSFETs that are in contact with the board. It is also a pretty good way to cool the entire electronic system. I am curious about the thickness of the paint insulation on the aluminum case, to see if it is safe in case of contact with the metal bars of the circuit, to prevent the short circuit between them. No matter how hard I tried, I couldn't get through the paint insulation, so I could say that it's pretty safe considering the spacing between the metal bars and the case. Now let's assemble the controller, connect the most necessary peripherals and do some programming on VESC tool to see it in action. Now it is time to dive into programming. The software is available on the internet and is free. But it would be good to make a small donation because the guys who worked on this software have done really great job. About software, because it seems quite complicated, I don't want you to worry because we will need only a few things. The first thing is to click the Auto Connect option to connect the computer to the controller. At the bottom right, you will see the port which device is connected. On the right side of the software, there are several meters, which is the controller's readings and measurements that we can see in real time. To enable that, we must click on the RT selection box. On the left side of the program, we see the motor settings and the app settings. Also, they are in groups. Once we make any change on the motor settings, we should press the M box with the arrow pointing down, which means saving the motor settings data to the controller. When we change the app settings, we should press the A box with the arrow pointing down, which will save the app settings. Now let's look at the most basic settings of the motor that we will need to change in the future. In general field, we see some other windows: sensors, current, voltage, RPM, wattage, temperature, BMS, and advanced. In sensor port, if our motor is working with Hall sensors, we must select a Hall sensor option. In the current window, the most important options that we can adjust are max motor phase current, max battery line current, and max regen current. In the voltage window, we must select the maximum and minimum voltage of our battery pack. Leave the rest windows as it is and go to the welcome window of the software. There we have the option with Setup Motors FOC. In this specific setup, we will learn the motor on the controller. There, the controller will do some operation on the motor, and through the feedback it will be able to read some characteristics from the motor. But it will also need some information from us, which we will insert manually. About BMS and duty cycle, we leave it as it is. Here we must choose our type and size of the motor. On battery settings, we must choose our battery type, battery cell series, and battery capacity. On the setup window, we must insert the wheel diameter and motor poles, which is very easy to measure as I will show you now. We need this number so the controller can calculate the actual speed of the vehicle. For wheel diameter, we just need to measure the diameter distance of the motor with the tire. For motor poles, you must make some connections. Just take one motor face and connect it to the other. Like that, we will have stepping resistance when we rotate the motor. Find a starting point and turn the motor 360 degrees and count the steps. After that, just put the number on the section. In my case, it is 30 counts, which means 30 motor poles. At the end, we press the run detection to let the controller start the auto-learn mode. The automatic learning just finished. The controller at the end gives us the results that were collected from the motor. At the end, the application asking us for rotation direction of the motor that we need. Now it is time to learn the throttle. To do that, we must go to Setup Input. Here we must choose Twist Throttle, which is also same operation for the thumb throttles. You can hear the motor is running very smoothly and it is ready to install it on the vehicle. Before closing today's video, I would like to play a little with the flux weakening of the controller to see what RPM speeds we can get from there. And yep, we have crazy speeds just from 36-volt battery. The first part of the video for today just finished. In the next video we will see much more interesting things. So, see you in the next video.